In this last lesson for homework packet 5.1, we're still going to look at systems, but instead of systems of equations, we're going to look at systems of inequalities. So here's the example we want to work through with a system of inequalities. You'll notice that just like systems of equations, we have a bracket here which combines the two inequalities into a set of inequalities, which means that they're related to each other, which means the x's are the same and the y's are the same. So these two equations are grouped together to say the variables represent the same things. So what we're interested in is looking for the sets of xy coordinate points that work in both inequalities at the same time. Now, when we were doing this with a system of equations, we'd graph both equations and we'd look for the point at which the two graphs intersected each other, and that xy coordinate was the solution to that system of equations. With a system of inequalities, things are a little different. Notice what the directions up here are phrased as. Graphically show the solution to the system of equations. The reason we have to graphically show the solution is because there isn't a single solution. There's an infinite number of solutions. So we want to be able to show that graphically. Here's how we do that. We're going to start by graphing each of these equations, or each of these inequalities rather, on the same coordinate plane, just like we would normally do. So let's look at the y is greater than 2/5 x minus 3. I'm going to go down to -3 because that's my y-intercept, and then my slope is up 2 over 5. Up 2 over 5. Now I can also go down 2 and to the left 5, down 2 more and to the left 5 more, to get a few more points to be able to connect the dots. Now, I'm not actually going to connect the dots with a solid line. Here's why. Because the inequality here does not have an equal sign. It's only y is greater than 2/5 x minus 3. So because it's y is greater than, what it means is that the actual line does not represent the solution. So what I'm going to use is a dashed line. So putting a dashed line through here shows me that any point along this line that I just graphed isn't actually a solution of that first inequality, because it says y is greater than. Here's how I approach it from this point. Y is greater than. If I look and I see that the y-axis is the vertical axis, so I know that y is up and down, and it says y is greater than. Greater than on the y-axis implies up. So greater than is anything. I always like to look at the y-intercept that I had, and I go up on the y-axis. That means everything up here is part of the solution to that inequality. In other words, every single point in that region that I just shaded is a solution to that first inequality. Any xy coordinate point will make this first inequality true. Any xy coordinate point below that dashed line that I drew will not work in this inequality. So let's take a look at the next inequality now. We've got y is less than or equal to 4/3 x plus 2. So I'm going to go to the 2, my y-intercept, and put a point. And then I have a slope of 4/3. So that means up 1, 2, 3, 4, and to the right 3. Up 1, 2, 3, 4, and to the right 3. To get some other points, I'll go down 4 and to the left 3. Down 4 to the left 3. I'll do that one more time. Down 4 to the left 3. Now, because this inequality has the equal part with it, I know that my line right here is actually a part of the solution. So notice I'm making it a solid line. The dashed line says it's not a part of the solution. That's exclusive. And the solid line indicates that the line is part of the solution. So that's the solid. That's inclusive. Now, it says that y is less than or equal to 4/3 x plus 2. So if I go to my y-intercept right here, on the y-axis less than is actually down. So it's everything underneath down here that represents the solution to that inequality. So we found the solutions for each inequality separately. The question now is, how do we find the solution to the system of inequalities? And just like system of equations where we were looking for the point of intersection, here we're looking for an intersection, but not just of a point, but an entire shaded region, which is all of this region right here, where the green and the blue overlap each other. So this region right here, every xy coordinate point in this region right here is a solution to this system of inequalities. If I pick any point outside of that black shaded region, it may work in one or the other or neither, but it will never work in both. The only xy coordinate points that work in both equations at the same time are in that shaded region. On your homework packet, make sure to clearly and boldly indicate that overlapping shaded region as your solution.